This video is going to look at multiplying and dividing our complex numbers. And if we have one of our complex numbers here, we'll define this as z sub 1. The trig form is r1 multiplied by cosine theta sub 1 plus I sine theta sub 1. And then our second complex number here would be z sub 2, and we'll define that as r sub 2 cosine theta sub 2 plus I sine theta sub 2. So if we're going to take and multiply the two complex numbers together, z1 and z2, then the form is we're simply going to multiply the r values together. So we're going to simply multiply here. And then we're simply going to take our angles, theta 1 and theta 2, and add those together. So with multiplying, it's very easy. We just multiply the r, and then we add the two angles together. And then when it comes to dividing, we're simply going to divide the r values, and then we're going to simply subtract the angles. So it's going to be the theta sub 1 minus theta sub 2 because it's r1 divided by r2. So let's look at an example first on how we can multiply. If we have the following complex number, we have 3/2 cosine of pi over 6 plus I sine of pi over 6. And we're going to multiply this by 6 cosine of pi over 4 plus I sine of pi over 4. So if we use the formula above, we're multiplying. We're going to multiply the r value. So here we have 3/2, that is our r1. Over here, 6 is r2. So we would have 3/2 multiplied by 6, or we could think of that as 6 over 1. And then we're simply going to have the cosine of pi over 6 plus, so here we have theta 1 and theta 2 would be plus pi over 4. And then of course we would still have the I sine of pi over 6 plus pi over 4. So then 3/2 times 6, that would certainly just be 2 goes into 6, 3, so 3 times 3 is 9. And then we would have our cosine of pi over 6 plus pi over 4. So if we're going to add, we need a common denominator. So here the common denominator would be 12. So 6 into 12 is 2, so that means we would have 2 pi over 12. 4 goes into 12, 3, so that would be 3 pi over 12. So therefore we get 5 pi over 12 plus I sine, and again the same angle, so that would just be I sine of 5 pi over 12. And this here is the answer. Now there is a little bit of a shorthand notation that I use here to write this. Instead of writing cosine 5 pi over 12 plus I sine of 5 pi over 12, you can do that, and they're going to be the same angle here, so it's a lot easier. We could actually write this, and you may see me later on abbreviate this. Instead of saying cosine I sine, I'm just going to write CIS 5 pi over 12. So this is a little bit of a shorthand, so you don't have to write this out all the time. And this basically means 9 times you have the C is the cosine of 5 pi over 12, and then IS would be the I sine of 5 pi over 12. Now, if you wanted to, you could actually take the cosine of 5 pi over 12, the sine of 5 pi over 12, multiply that by 9, and you could get the answer in standard form. But in this case, we're just going to leave the complex number in trig form. Okay, so now let's look at an example if we were going to divide. Let's say that we have 9 cosine of 20 degrees plus I sine of 20 degrees. And we're going to divide this by 5 cosine of 75 degrees plus I sine of 75 degrees. So now if we go in here and look at the formula for division, we have R1 over R2, and then we're simply going to subtract the angles. So it's very similar, except for we're going to now actually divide. So we have the R values here. We have R1, this is R2. So we would end up with 9/5. And then we're going to take theta 1, which is 20, and then theta 2, which is the 75, and we're simply going to subtract. So we would have the cosine of 20 degrees minus 75, and the same thing over here for the sine function. We would have 20 degrees minus 75. And if we were to then to simplify this, we would actually take 20 degrees minus 75, which is going to be equal to a negative 55 degrees. Now, there's nothing wrong with this answer. This is a correct answer. Now, I will tell you that a lot of times we're not going to leave the angle as a negative angle. In other words, if we were to locate a negative 55 degrees, negative 55 degrees is located down here in the fourth quadrant. And we may want to look at what is going to be the positive angle if we went all the way around this direction. Well, that would simply be all the way around is 360, and if we take away the 55 degrees, then we're going to be left with 305 degrees. So instead of using a negative angle here, we could certainly write this then as 9/5 cosine of 305 degrees and the sine of 305 degrees. So it's a good chance you're going to see the angle as a positive angle. So if you're looking at this as a multiple choice question, either one of these answers would be correct. And I would have a feeling that if you had a negative angle, they're going to actually change it and make it positive. So once again, the only difference here with multiplying and dividing is you're simply going to multiply the R values, add the angles, and when you're dividing, you're going to simply divide the R values and then this should be subtract. We're going to subtract the angles when we're dividing. So you can kind of think of this like when you multiply, as an example, if you were to multiply x squared times x cubed, you're going to add exponents. So over here we're adding the angles, and if you were to take something like x to the 7th divided by x to the 4th, what do you do with your exponents? You're going to subtract. So here we're subtracting the angles. So that's kind of one way to think of the operations that we're performing. Okay, let's look at one more example. And the next example I'm going to look at, the problems could be given in standard form where we would have 2 plus 2i multiplied by 1 minus I. Now here, the standard form, because remember our standard form is this a plus bi, and here I want to change this to our trig form. And if we want to change this to trig form, once again, that means we need to find what's the r value and what is theta. So we need to do that for both of these numbers. So if we start with the first one here, 2 plus 2i, then I would start first of all by looking at where is this located. Well, we're going over 2 and then up 2. So that real number or complex number is going to be located here in the first quadrant. So therefore, if I go to calculate now the r value, r is going to be equal to the square root of 2 squared plus 2 squared. So that would be equal to the square root of 8. Or we could actually then simplify that. That would be the same thing as 4 times 2. So that would be 2 square root of 2. And then, of course, we need to calculate the angle. What is this particular angle here? Well, we can use the tangent function, which would be the tangent of theta is equal to 2 over 2. So using the inverse tangent, and 2 over 2 would simply be 1, so we would take the inverse tangent of 1, we can calculate the angle. Now we can look at this and we'll know, and if we did the inverse tangent of 1, that means where is y divided by x equal to 1, and that's going to occur at pi over 4. That's where your x and y values are the same in the first quadrant. So there we have our first complex number then is z1 is equal to 2 square root of 2 cosine of pi over 4 plus I sine of pi over 4. All right, so now we want to do the same thing with the second number. So once again, we might want to first realize where is this point going to be located. It's going over 1 and negative I, so it's going down 1. So this number is located in the fourth quadrant. So if we're going to calculate the R value, then R2 is going to be the square root of negative 1, or positive 1 squared plus negative 1 squared. So therefore, this would be equal to the square root of 2. And then if we're looking for the angle, we know tangent theta is going to be equal to the negative 1 over 1. So that means the inverse tangent, well, negative 1 over 1 would just be a negative 1. So if we're looking for the angle, where do we have our y divided by x? Where does that equal negative 1? Well, if we're in the fourth quadrant, then we're looking for this angle, and the only place that your x and y values are the same, that would be located at a negative pi over 4. So therefore, this number would be, if we call this z sub 2, we would have the square root of 2 multiplied by the cosine of negative pi over 4 plus I sine of negative pi over 4. So here we have converted from standard to trig form, so 2 plus 2i multiplied by 1 minus I. So here we want to multiply z1 and z2. Well, we know that if we're going to do that, we're simply going to multiply here r1 and r2. So this would be 2 square root of 2 times the square root of 2. Well, square root of 2 times square root of 2 is going to be equal to the square root of 4, and the square root of 4 is 2. And if we multiply that by the 2 out front, we're going to end up with 4. And then remember, when we are multiplying, we're going to take our angle here, which is theta 1 pi over 4, and then theta 2 is negative pi over 4. So pi over 4 plus a negative pi over 4, then that's going to cancel to 0. So that's the cosine of 0 plus I sine of 0. Whoops, not theta. That would be equal to 0. Now notice here, this is in radians, so the angle here is cosine of 0 radians, so we do not put a degree symbol here because this is the angle in radians in this case. So now of course we could make it 0 degrees because that would be the same location as well, but here since we're dealing with radians, we would leave it in that format. So if we leave the answer here, this is our trig form. And if we wanted to, because the original problem started out in standard form, 2 plus 2i times 1 minus I, then we could certainly change this to standard form. And to do that, we would just simply take 4 times the cosine of 0 plus 4 times the I sine of 0. Well, the cosine of 0, that's going to be equal to 1. And then I sine of, whoops, not theta, I sine of 0, that means we would take sine of 0, which is going to be 0. So therefore, 4 times 1, we would certainly end up with just a number of 4. And technically this would be, I could write it this way, as 4 plus 0i, which means we do not have the imaginary part, we just have the real part of 4. So here we went through the problem of looking at 2 plus 2i multiplied by 1 minus I. We converted the standard form into trig form, and then we were able to multiply these together. and we came up with an answer of either 4 cosine 0 plus 4 sine. And if we could change this from trig, then down here we would end up with standard form. Now, what would happen if we were to take the exact same problem, 2 plus 2i, and what if we were just to multiply it this way? We did this before. We could actually just multiply this in standard form using the FOIL method. So we could take 2 times 1, and then we could take here and get, whoops, wrong place, 2 times negative I, so that would be a negative 2i. Multiply here, we would get a positive 2i, and then here we would get a negative 2i squared. So the negative 2i, the positive 2i is going to cancel, and then we have 2 minus 2 times I squared, and recall I squared is really a negative 1, so therefore we get 2 plus 2, which is equal to 4. So we can always work this out in standard form, but if we have the problem in trig form, the multiplication is also just as easy, because in trig form, you're just simply multiplying the r values and adding the angles together. So this verifies that we end up with the same answer of 4 here as we do up here. So here you have the formula for multiplying and dividing complex numbers in trig form, where you simply multiply the r values and add the angles for multiplication, and you divide the r values and subtract the angles for division.